All right, let's get this started. So, most of you probably know Justin, but for those of you who don't, Justin, could you give us just a quick intro and also say a few words on what you are currently focused on?
Yeah, so I'm a researcher at the Ethereum Foundation. I'm now part of the architecture team. There's been this massive reorg at the EF. And so there's this new cluster of teams called Protocol. There's about 91 people in that cluster, and I'm in a team called Architecture with 5 people. I've been at the EF for close to 8 years now. And the topic of research changes every year. But what I'm doing right now is partly what I call gigagas L1. How can we scale the L1 to 1 gigagas per second? I'm actually giving a talk on this at EFCC in just a couple hours. And the basic idea is to use ZKVMs so that validators can verify very big blocks without having very large computers. And then the second thing that I'm working on is kind of this longer term idea called the beam chain, which is meant to radically upgrade the consensus layer and make it as good as we can, in particular having post-quantum security, things like APS, attested proposer separation, 3SF, 3-slot finality, much faster finality, faster slots, just better everything. So yeah, we had Beam Day yesterday, which was a huge success. And on the ZKVM side of things, every other day is a massive success. Right? We have breakthrough announcements every day, almost. And just today, Zisk announced that they've also achieved real-time proving. So this is the 4th team that have achieved real-time proving.
Exciting stuff. So much going on. But to take one step back, so you're one of the reasons many of the teams that are building things around pre-confirmations, spaced rollups, Blockspace futures are here in this room and actively working on some of these problems. Wanted to kick things off by getting your view on what the current state of things is and how far do you think we've gotten and how far do we still have to go?
Okay, so since we're starting the based topic, I'm going to put my based glasses on. So I think we're making a lot of progress. One of the things that we're making progress on is general acceptance of the idea. I have this meme that when I introduced base sequencing, I was the only one who believed in it. It was very contrarian, and it's kind of this up-only pilling process. And I think I'm glad to say that now within the EF, I think it's a kind of an accepted concept, and I don't think anyone really disagrees with it at this point. The other thing that we're seeing is that very large infrastructure providers are also starting to appreciate it, and these are like conservative institutions. So I think the best example here might be Lido, that are have finally accepted to allow their operators to run commit boost, which is a massive breakthrough and a big unlock. Yeah, thank you, Lido. This is a great unlock. So I think we now have 12% of the validators running commit boost, and I'm hoping that this will grow 20, 30, and that's enough of adoption to have pre-confirmations, execution pre-confirmations for base rollups. It looks like we also have a bunch of teams building on top of commit boost. I haven't been following the details, but Drew tells me there's like a handful of teams doing that. And we're also dramatically improving the based ecosystem in multiple ways. So one very recent proposal, actually Barnaby went on All Cordes recently, is to shorten the slot durations to 6 seconds. I think that will dramatically improve the UX of the base sequencer, making it more attractive. Another thing that I already mentioned is that we want to dramatically scale the L1, and Dankrat has this proposal, this EIP, to basically scale the gas automatically, the gas limit, by 3x per year. And that is going to make the L1 much more of an economic contender in the global set of chains, and it will basically change the shift of power, whereby there will be more of an incentive for the L2s to become based and connect to the economic activity that is happening on L1. And another thing that's happening just generally is that the infrastructure is getting more and more mature and is not leaking as much MEV to the sequencer. So right now, there's kind of this short-term incentive whereby it's good to be a sequencer because you're leveraging on sophistication of applications, wallets, users, and whatnot. But as the ecosystem matures, it learns how to recoup and recapture MEV so that it doesn't leak to the sequencer. And so now there's less of an incentive to be a sequencer and more of an incentive to adopt a shared sequencer like the base sequencer.
So from a microstructure perspective, today we have the PBS supply chain. We have out-of-protocol sidecars like commit boosts that enable pre-confirmations and Blockspace futures markets. But when we think about some of these big changes that are up and coming, do you think that's gonna impact the microstructure in a way that affects some of these things that are being built today? And if so, how?
Okay, microstructure. I mean, one interesting thing is that the structure of the market is constantly changing, and there's always new innovations. And if you go to mevboost.info, you can see the shift of power between the builders. You have a top builder, for example, Builder 69. Back in the early days, he's just completely disappeared, and now we have BuilderNet and whatnot. I guess one piece of alpha that I learned recently is that Beaver Build will be producing 0 blocks by the end of this year. All of that flow will be going to BuilderNet, and basically we're going to see, I guess, potentially Titan and BuilderNet as these two big builders. And actually, one point of reflection here is that I think we're in this extremely luxurious position where the top players in the pipeline are very, very Ethereum aligned. So yeah, Beaver, Titan, Flashbots, even though it's extremely concentrated, it's still very much aligned. And so that allows us to experiment without having to worry that bad things will happen. Yeah, I guess one thing that you guys have put forward as a potential change to the microstructure is this idea of bundle merging at the relay level. So one of the, as I'm told, actually by Alex, who's here in this room, that when a block is chosen to be the winning block by a relay, more often than not, there are bundles from other blocks that could be included and tagged on at the end without conflicting with these other transactions. And so what if basically the relay plays a little bit more of a builder role, and if there's builders that opt in with bundles that they want to be included with high priority, well, whenever they can be included, they will be included. And I think that's going to be an interesting shift of dynamics, and also one which will help these Blockspace futures, right? Because in some sense, futures is all about delivering the future, and if you have a better inclusion properties, you're more likely to be able to deliver it.
So I guess one thing that is required for Blockspace futures and pre-confirmations is a deterministic look ahead. And so that often lies at odds with the boogeyman monster called multi-block MEV that has been theorized on. First of all, I wanted to get your perspective on has your view or the view in the research community changed on multi-block MEV? And secondly, how do you think about the trade-off between certainty and being able to provide these like value-add services like pre-confirmations, Blockspace futures versus the boogeyman that is multi-slot MEV?
Yeah, so just thinking practically instead of like from first principles, I think what will happen is that for the foreseeable future, we're just going to have this look ahead. Actually, talking about look ahead, one thing I'm very, very pleased about is that we have the EIP that provides a fully deterministic look ahead over one epoch that's coming in Fusaka, and that will make pre-confirmations dramatically easier to build. But in the short term, there's a lot of ideas to review the MEV pipeline with hard forks, but none of them involve changing the existence of a look ahead. So we have Fossil, for example. We have the shorter slots. One thing that just came back on the radar, kind of, I was under the impression that the rough consensus was that we don't want to do it, but it seems like this has completely flipped. There's now a real appetite to do enshrined PBS within the L1, and this basically was one of the learnings and outcomes from the Berlin meetings that we had earlier this month. Now, on the topic of multi-block MEV, as far as I know, we haven't seen it empirically. And it's been quite a long time, and the infrastructure is there to do it, right? We have large and sophisticated operators, for example, Kiln, that are willing to do many, many things to push the limit, and they're like technically competent enough to do multi-slot MEV if they wanted to, but as far as I know, they're not doing it. And multi-slot MEV is something that could be organized through relays or large builders and whatnot. I guess we have Kevin here from EVGAS who has been talking about multi-slot MEV as something that's potentially unlocked through his platform. I'd be curious to hear his take if there's any evidence of it. My hope is that it's not too impactful, like it quite likely non-zero, but like hopefully not too big. And I believe that there's some sort of a paper out there from, maybe it was Thomas who wrote it, or Julian or something, that basically argues that multi-block MEV is not a big thing, at least in some contexts like DEX is. Now, if we shift away from the pragmatic stuff and for the foreseeable future and think about fundamentals, APS is kind of one of the big things in the beam chain. And my hope is that we can have an extremely simple design and one which allows for pre-confirmations. There's a few variants of APS that don't allow for pre-confirmation. So one of them is real-time execution auctions. And it seems like people don't really like that for multiple reasons, one of which is that it really complicates the fork choice rule. And so, folks like Francesco don't really like it. And so if Francesco doesn't like something, it doesn't go in the L1. That's the rough heuristic here. And then there's this other design, which Julian has been thinking about, which involves this very fancy threshold encryption. So basically you'd have a committee of validators who would in real time decrypt a bid or produce randomness in real time. And the thing is that we don't really like threshold assumptions at L1. Like we would rather not have them, only one of n assumptions or things like that. And so right now my default mental model is that we relatively likely are going to land to something which is fairly close to what we have right now, where we have a reasonably long look ahead of one epoch. Maybe that can be extended actually to 2 or 3 epochs, because that will dramatically simplify some pre-conf protocols. And there's been various flavors of APS. So there's the execution auctions, there's the execution tickets, and there's also what I call execution staking, which is basically the same thing that we have right now. You stake and then you get selected at random. And it looks like people don't like the execution tickets because they're more centralizing. Basically, the idea here is that you take a big risk when you buy an execution ticket because you're paying up front and your money is gone. You've paid for your ticket, and then it becomes a lottery. and that's very risky and centralizing unless you're very big. Whereas staking is you're only paying with opportunity cost, and so it's kind of much smoother. And if you don't win, then it's fine. You just lost a little bit of opportunity cost. So yeah, those are some thoughts on APS.
So across all these different approaches to solve APS, is there a specific direction that you would say the community is leaning towards more or less?
So when you look at the Beam chain and the fundamentals of the future of Ethereum, I'd argue that there isn't that much contention. Like people, basically the contention happens in the model that you're setting. So, for example, right now there's a little bit of a discussion around how we should do finality. Like, do we want dynamic availability, which is this like really strong World War III grade kind of property, or do we want to fall back to kind of more traditional BFT style finality, which might have, instead of three slots to finalize, it's maybe only 2, or maybe even less than that. And yeah, like here there's kind of a hard trade-off, I guess. And then the other place where there's a hard trade-off is potentially with APS. And so even, I think we're at a point where we have a good understanding of design space, and now we just need to make some sort of opinionated choice. And I think this choice will partly be data-driven. So if over the next, call it 1 to 2, 3 years, we see a massive proliferation and massive success of pre-confirmations, that's going to tilt towards the side of having a look ahead. If there's no pre-confirmations and the idea just doesn't work, then we might as well look at some alternatives more seriously.
Talking about look ahead, so even if you have 2 to 3 epochs with a deterministic look ahead, you still really won't be able to do long-dated block space futures. And I'm wondering if you have thought about a design that could still facilitate that.
Okay, so you can't do deterministic long-dated futures, but you can do probabilistic long-dated futures, right? Because if you're Coinbase, for example, you own 20% of the stake or whatever the number is, then you know that over a long enough period of, let's say, a year, you'll be able to deliver on 20% of blocks on average. And for some applications, like rollups that are just their own silos, and it doesn't really matter when they settle, that's perfectly fine, and they might be willing to buy these long-dated futures from someone like Coinbase. I guess one obvious thing that comes to mind here is that it favors the big guys who are big enough to be able to sell these futures, and so wouldn't it be nice if we had, I guess, an opportunity to have small players, small stakers, be able to commit stake? And I mean, I'm just thinking out loud here, but like this could be a service that Lido provides. I don't know. It could be an opportunity for a new protocol at a higher level of the stack than just the staking. But yeah, one thing we could do is kind of extend the look ahead more aggressively, so it could be several hours or maybe several days. The main trade-off here is that it affects the validators that want to exit, right? Because if I'm selected, in tomorrow to be a validator, then I don't have the incentive, or I have less of an incentive to exit. I mean, one thing that we could potentially do is, I'm just, again, thinking out loud here, but an individual validator could say, actually, here, rainbow staking, an idea from Barnaby, right? Like, today, what does it mean to be a validator? It means multiple things. It means that you're a block proposer. It means that you're an attester. It means that you're an includer, meaning that you're helping with censorship resistance, including transactions from the mempool. There's an opportunity to unbundle these things. And maybe there's an argument to be said here that if you're an attester, you should be able to exit immediately. If you're an includer, like same thing. But if you're a proposer, then the exit window is 1 month. Why? Because we want these like month-long dated futures, and that's a valuable service for the ecosystem. Interesting design space.
Okay, and just also thinking about some of these major changes, reshuffling the landscape, specifically thinking about the beam chain, snarkifying the EVM, and like the role of being a node operator or a validator looking potentially different. Do you think that's going to have an impact on the industry at all?
So the major impact of ZKVMs on validators is actually very counterintuitive. Is that instead of having to run on a laptop or on the cloud somewhere, you'll be able to run on much less powered machines. So you'll be able to run, and this is the new meme, on a Raspberry Pi Pico. So for those who are not familiar, the Raspberry Pi, the normal one, is it costs $50 to $100, and it is reasonably powerful. You can even run Geth on it and like barely keep up with Ethereum L1. But with the Pico is the next level, right? It's a $7 device. It consumes 1 watt, and it's powerful enough to be a fully validating Ethereum client, which is kind of mind-blowing. And the reason is that to be a fully validating Ethereum client, you need to just download these short proofs and verify them, and it's going to take a few milliseconds, and you're all good. So that is the major impact for the validators. One thing that I expect we'll see at some point is Fossil, and that's going to have a fairly big change, a very positive big change for the block building pipeline. So basically, right now we're in this really okay. So going back to censorship, there's some good news and some good news, some bad news, and some even better news. So the good news is that there's extremely little censorship in practice. Why? Because Tornado Cash is no longer part of the OFAC list. And actually I have a story that hopefully I can share from the ultrasound relay. So the ultrasound relay is connected to about 80% of the validators. And the 20% that don't connect are mostly regulated entities that won't connect because they want to see their blocks filtered with OFAC stuff. And so the ultrasound relay basically recently has this new filtered service that for those that specifically ask will do the filtering for them, and hopefully that means more of the validators will connect. And I think one of the validators connected, and in doing so there was this bug where accidentally it was filtering for all the validators for several weeks. And it was only discovered after an actual OFAC transaction went through the ultrasound relay, and that literally took weeks. So in practice, there's no censorship. Now the bad news is that if there were to be censorship, if tomorrow President Trump or whatever like completely changes his opinion on things, then we would be in a fairly bad position, partly because the self-builders, like basically the validators that opt in to help with censorship resistance, are a small minority. So there's only about 10% that kind of opt in to self-building with things like min-bid, and that's quite bad. But with Fossil, basically we would have 16 includers at every slot. So you can think of it as being, roughly speaking, 160 times better, right? Because you have 16 times more per slot, and you have 10 times more slot where you have that censorship resistance. And the way that it would work is that you'd have these very weak entities called includers who would be helping take transactions from the mempool and force include them on chain. And the good news is that you can use ZKVMs to make the includers extremely small. But there is like one little thing that they that they need, at least in the short term, is to keep track of the balances, the nonce, and the public keys of the various addresses, so that that's the kind of the minimal information required to know whether a transaction in the mempool is valid. And I think we're talking about like on the order of 10 gigabytes of data. I think even less. So you can have a Raspberry Pi Pico with an external drive that has 10 gigabytes, and that will be enough to be an includer.
Okay. So we are almost at time. So before I open it up for questions briefly, wanted to ask if you have any alpha that you can share with us.
Alpha. Yes, I do. So I'm not sure if I can share the name just yet, but I'm very, very excited that someone extremely respected and extremely competent will likely be championing the native rollup effort. Now, I've been working on multiple things, base rollups, native rollups, ETH proofs, and the Beam chain. And I just can't do all of these things, and so I have to delegate. And I'm very, very happy with the work that Drew has been doing. The Ethereum Foundation gave Fabric a grant. I'm basically hoping that this is kind of a similar thing with this individual. And it's also great for base sequencing. Why? Because there's a lot of synergies between base rollups and native rollups. When you do the two together, like magic thing happens, in particular related to delayed execution. And that facilitates the real-time proving, and therefore makes it much, much easier to do synchronous composability, and then that makes it easier to have network effects. So yeah, that's one thing I'm excited about. No, that's pretty much it. No more alpha, sorry. Do you have alpha? I want alpha.
No alpha for me, but any questions from the audience before we close this session?
Thanks. Excuse me. This isn't so much a question, more of a calling out the multi-block MEV thing. There have been instances of it, mostly in the DeFi exploit world. Like 3 years ago, I think it was one of the Cream exploits. Someone pushed the price up on an AMM, did the Oracle update, then censored the Oracle updates for the next like 2 or 3 blocks just by bidding up the gas price so that the Keeper bot couldn't get through, and then stole a ton of money because the TWAP was messed up. So I don't like the term multi-block MEV because normally it just means like DeFi exploits, but like yeah, there have been instances of it in the wild with like a 2 to 3 slot window.
That reminds me of FOMO 3D, for those who remember. Many, many years ago, there was this game where there was a pot of money, and you could buy a ticket to win, and basically the last person who placed the ticket would win after a certain timeout. And basically the winner, who might be in this room, I don't know, basically censored the chain by DOSing the mempool over the timeout period.
Any other questions? In the back.
Thank you for sharing. I'd like to ask a question that is on the networking or the P2P layer of Ethereum. What type of role do you think that plays in terms of scaling Ethereum? Do you think that is part of the bottleneck of scaling?
Yeah, so historically, networking has been an afterthought for Ethereum. For example, on the Beacon chain, like what we did is we just reused libp2p. We did a lot of work, with client diversity and with interop and with standards, but we didn't do much work at all on performance. So I think there's a lot of low-hanging fruit. As part of the Ethereum Foundation reorg, we now have a dedicated networking team. There's 3 people on it. It's led by Raul, who kind of is this libp2p OG, and he's only been there for a few months, but he's doing an amazing job, in my opinion. So we're now taking networking very, very seriously. We also are potentially going to be working with external partners like Quadrivium. For those who don't know, Quadrivium is like one of the alternative clients on Polkadot, and they're the creators and maintainers of libp2p C++. And they came to Beam Day yesterday, and they're doing all sorts of fantastic networking stuff. And so we might be working with them. But yeah, in terms of the new strategic objectives that the Ethereum Foundation listed for the next 12 months, we have scale DL1, scale DL2, improve UX, and networking plays a key role in the first two. So for PeerDAS, for example, there's a lot going on with networking. We also want to kind of restructure the slot, and that will have impact on networking. We want to be able to gossip blocks much faster. You know, there's all of these fancy words that are thrown around, like RLNC or something, like all sorts of fancy erasure coding ideas, and of course all of the discussion around shortening the slot time is so. If you are a networking expert, because, for example, you're doing low latency searching or building, please DM me. We will be likely growing the networking team and growing this muscle.
One more, if you have time.
Go for it.
Over here. What do you think the constraint of the network's going to be in like 3 years? Like, what'll be the bottleneck that we see?
Hi, Drew. Good to see you. What is going to be the bottleneck? You mean for what? For the L1s?
Yeah,
scaling?
for the L1 specifically. So yeah, do we still think it'd be networking or sharing of blobs or capacity of the L1?
Yeah. So if you think in terms of fundamentals, I've said this multiple times. You know, there's multiple resources at play in consensus. Storage, execution, disk I/O, all of that can be handled with ZK. The main fundamental bottleneck is going to be bandwidth. And Ethereum is especially impacted by bandwidth because we have this constraint that we want home internet connections. And what data-related sampling gives you is basically a multiple over the internet connection. So the rough multiple is 100. So all of the Internet of Finance should fit within 100 internet connections, and I think that's going to be the major bottleneck. I mean, going back to shorter slots and things like that, what I expect will happen is that in a very decentralized network like Ethereum, we won't be able to bring the slot duration down, let's say, under 1 second, maybe not even down under 2 seconds. Let's assume that we do like amazing kung fu networking and we get it down to 1 second. My thesis here is that 1 second is still too slow, right? People want the real-time stuff. And so the only way forward is to invest in pre-confirmations. Now, there's multiple ways to tackle. Actually, that's another thing. Like, not only are people appreciating base sequencing, but people are also respecting pre-confirmations much more nowadays within the EF. It used to be a crazy idea, but now it's kind of accepted. And Dankrat especially had this kind of interesting thought, which is that we could have some sort of special hard fork that does pre-confirmations, but that feels very far-fetched, and or maybe for the longer term, like things like the Beam chain. We could just have the ecosystem just off-chain figure out pre-confirmations, but it leads to a lot of fragmentation, and it leads to potentially breaking up of network effects and complications. But then maybe there's this middle ground which is attractive, which is that the Ethereum Foundation or some other entity comes up with a robust stack which is kind of socially expected to be bundled with the client. And so you could think of it as kind of being the equivalent of the Builder API and MEV Boost. And so there is a possible future, at least according to Dankrat, where maybe things like Commit Boost are kind of bundled with the clients, and it's kind of turned on by default or something. which would dramatically make the dramatically help the timelines for pre-confirmations. And I guess that's a similar thinking. I just made the link here. That is similar thinking to Dankrat's EIP to increase the gas limit. So normally EIPs are for hard forks, but like this specific EIP is a weird one where it's more of a default setting in the client, which is off-chain infrastructure. So I think just zooming out, the EF is trying to be more pragmatic and less purist, and things like this design space, which were previously ignored, I guess, are now being explored by folks like Dankrat.
Thank you.
All right. Thank you, Justin.
Thank you. Thanks.